Alright guys, I will go ahead and record this video, and I do hope that you are following me. So this video is pretty much about our day 8 in IT Foundation and AWS Cloud Training, codenamed iFACT. This class is the class that allows you to get familiarize yourself with the IT foundations, looking at all the cores of IT from hardware to software to networking to virtualization, security, and finally cloud. In the cloud part of it, we'll teach the cloud concept and again spend a lot of time in use cases. Okay, so in this class, I deem it, and from what I've gathered from other people, the suggestion was that we should take the people through the IT foundations, giving them the whole idea of what IT is all about. That way, they will gain that knowledge that they need to be performant when they get a job. And again, they have to scale the interview with the managers who has over 5 years experience and more. So moving forward, what I'm going to do now, I'm going to share my screen because I wanted you guys to have a clear understanding of what I'm about to do. So while we were in the class yesterday, something strange happened to us. We got cut off, completely cut off, and we weren't able to do what we set out to do. And today, I decided to create this video for their class so they can catch up in the concept that I was trying to show them. Now, I'll try to run them over the introduction to Classfull IP addressing. I know this is a very important topic, and I'm not going to go step by step with the networking aspect of things. We don't want to be shallow, and at the same time, we want to make sure they understand the majority of the concepts. So when they see an IP address, they will understand how IP address works. Okay? Now, I am going to share the screen with you guys. As always, I usually share the first screen. Now, it's being recorded, okay? So I'm going to go ahead and work on it. Okay? I'm going to go ahead and work on this. Just give me a few minutes. I just noticed something. Okay. All right. Let me see. It's not working well. So let's see why it's not working well. I'll fix it. See why it's not working well. Okay. Screen number 1 should be here. I think I know what's going on. Guys, let's see. Alright, fine. I hope that is good. I hope it makes sense. Okay. Okay. Alright. I think I'm sharing the right thing. I believe I'm sharing the right thing. So, okay, let's see. Yeah, I believe I'm sharing the right thing. Okay, moving forward. Sorry about that little brouhaha there. So we're gonna go to Paint. When we get to Paint, we're gonna do a lot more stuff on the Paint. And I hope you guys bear with me. It won't be long. It'll be over before you know it. Okay, I'm gonna open up Paint. The reason for opening up Paint is very clear. If you use Paint, it will really address some of the confusion we have in setting up what we need to set up. So I'm going to go ahead and tap the Paint again and open it up. Okay. All right. Okay. All right. So this is Paint here. I will kind of reduce it. And before we start, I wanted to introduce something to you guys. Okay, this is good. Looks good. Looks all right. So what we wanted to talk about is introduction to Classfull IP addressing. In Classfull IP addressing, for those of you that know what IP addressing is, you will understand that there's something called Classfull IP addressing. IP address is an address and having information about how to reach a specific host. Okay? So in IPv4, IP address is a 32-bit unique address. As you can see, it is in binary raised to the power 2 raised to the power 32. And what you see there are some of the high bits and some of the low bits. And as it's been identified, the computer understands zeros and ones. But the interesting part of it is that how do we translate all these things that the computer is doing? Okay, so let's move. Let's go into our book. We have a book that we use, a book that we put together, and it's still a work in progress actually, and we hope to use it to educate ourselves. So now I'm gonna go here and I'm get into the book quickly, and I will do it real quick, so I won't take much of your time. We'll go right here. So cloud movement idea, and it's gonna pop up real quick, and you'll see it pop up. Okay. Now, if you scroll down all the way down here, you will see a part of the network, a part that deals with the network. We wanted to do programming before this, but we realized that this is important too. We don't want to come back to it anymore at all. So last time we talked about the facts of the network as we started, and we immediately went into the class A, class B, and class C and class D IP addressing, or classless IP addressing. Okay. So now I wanted to expatiate on that. That's why I'm going to use Paint to help you understand that. So in class A, what's going into class A, some group of people that are smarter than we are figure that the number of nodes that could be held in class A. So it has a range. As you can see there, 0 slash simply says that all the rightmost and leftmost bits are 0. Pretty much everything is 0. So when you see that there, the 0 dot 0, let me light this a little bit. 0 dot 0 dot another 0 dot another 0. So I want you to understand this way. Okay, when you see this and this, I really want you to understand it this way. That this one represents some 8-bit, okay, and that this one also represents some of the 8 bits, and this one also represents some of the 8 bits. Okay, so with that being said, you will notice that when I come down here, I can write 0, and I can write this 0, 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 and I can write this 0 here. Okay. Alright, okay, that there allows us to write what we need to write as a number representing what the computer understood, or the encoded message that we give to the computer. For instance, we type capital A, I believe is 65 in ASCII. So to write to 65, you have to do something like, this is 128, so this is 64 here. So you have to do something like, you already know this is 128, right? You know that's 128. You know this is 64 here. You know this is 32. And you know this is 16, right? And you know this is like, I think 8. And you know this is 4. You know this is 2. You know this is 1, right? So you know all of that. 128, if you add all this number together, you get 256. So in this case, for the capital letter A is equal to like 65 in ASCII, right? So for that, you have to turn this one off, turn 64 on, then turn this one off, turn 16 off, turn 8 off, and then turn 4 off, turn this one off, and turn 1 on. So now you have what? You have 65. So I want you to look at this in this way for IP addressing. You look at it in this way, okay? I want you to look at it in this way, all right? For what it is, truly. It's just representing the numbers in a certain way. And those numbers here represented in a certain way have been designed in a certain way to represent something. So for a class A here, okay, let's do a class A here. For a class A, we remove this. This is class A. So for a class A, we're gonna be looking at what is the range of a class A. A class A is gonna go from, like I said, when you see the 0, you know what it represents, okay? So a class A is gonna go from the addressing is gonna do class A is gonna go from 0 to 127. Okay. So remember, when you see 0, I told you to look at the 0 as like this. This 0 here is 0. This 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 is 0. And this is 0. So this one is going to be the same thing. This is, okay, let me change it. This is also 0. This is 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 0. And this is 0. And don't forget to put your dots, okay? Put your dots here. You're going to put another dot here. And then the green one is going to be the same thing. It's going to be a 0. 0. Try to make it as small as possible so it can fit. So you have 0 here too, you have 0 here too, you have 0 here, you have 0, you have 0, and you have 0. And you have your dots here. So that's how you look at it. So each of this, when you look at the whole thing, is 32. You're looking at 32 bits. You're looking at the whole 32 bits. So let's represent the whole thing. You're looking at the whole 32 bits. Okay? This is what it is, 32 bits. Okay, so we highlight that. So that's what you're looking at when you see that 10 there. This 10, you're actually seeing 4 zeros, which makes the 32 bits that we are talking about. So now, if you are going from 0 to 127, it simply means that you are going from all of these being 0. This tells us that these are empty bits. There's nothing in it. But they could be populated. Imagine going from here all the way to 127, which in this case 127 will be, you look at 127 in the same way too, okay? If 0 is this, 127 should be 127. You have to convert that 127 to binary, just like we did. To get the 127 from binary, I believe you have to, you turn this one, you turn the 128 off, turn the 64 on, turn 32 on, turn 16 on, turn 8 on. I think you turn 4 on, turn 0 off. I mean, turn 2 off and turn 1 on. So now let's calculate it and see what we get. So this is, I believe this is 64 here. And you have 32 here. That is 96. Now 96 plus 16 is 102, 112. 112 plus 8 is 120, right? Okay, 120 plus 4 is 124. And then 125. So that simply means we have to turn this one on to. Make sense? We have to turn this one on to. So we have all of that. So you see, this is 4 here, this is 2 here, and this is 1 here. So when you add all this together, you get 127, and this one 128. Remember, it's from 0 to 255. So we have that. We put a dot here. Then this one is a 0, this 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 is a 0, and this is a 0. So you have 1, 2, 3, 4, 5, 6, 7, 8. Then you put your dot here. You go this, 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 yeah, this. And you put your dot here again. And you go this. Okay. So I'm gonna show you something interesting when I'm done with this. Okay. So you have 1, 2, 3, 4, 1, 2, 3, 4, right? So now you have the whole idea of that particular class. Okay. You have the whole idea of it. The range is you've recognized what the range is. So you go from all of that to all of that. So this is the range here for this class of IP. This is the range. It goes from 0, which is here, 0 to 128. So you have from 0 to this. So from here we can see something interesting happening. This tells us that all these places could be populated. All these places that you see 0 could be populated with hosts. But apparently this kind of IP addressing, we don't use it much. Okay? So when you see this kind of addressing where all the octets are 0, is class A. So you have from 0, 0, 0, 0 to 127. The net mask is 127, 255, 255, 255. This is what we call the class A. Okay? So all these places are populated. Once they are populated, so we know for sure we can go from 0, 0 to here. Once they are populated, we know we can go from 0 to 127, and everybody else is full. So all those places you have 0, we can have stuff in it. But when we have it like this, you see the loopback. This becomes the loopback. This is the loopback 127. Always remember that for class A, that's how it goes. Now for class B, so you have where class A stopped, that's where you start. Where class A stopped, that's where you start. So where class A stopped, that's where you start. The class A stopped in 127, that means you're going to start from 128. So to get 128, what do we do? Very simple. We do 1, and the rest is what? 0. We do 1, and the rest will give us a 0. There's many ways to do the same thing. So we can do this, we can do this, we can do that, we can do this, we can do that, we can do this, keep going until we get here. Okay? So when we get there, we put our dot like we've done before. We put our dot there. It's not big enough, I'll make it really big. I'll change the color too. So we put our dot there. So going back to what we have here, you see, starting from 128 to 191. So that's the range. The range is given 120. This one is 0 to 128. We know is how many? 128. Now we go from 128 to 192. How many? 64. So now you have, I think you have 0 here, 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 0 here. These are the places where you have the host to live on. You have the host will live in those places. Okay? So you do the same thing for here, you do the same thing for here. And you do the same thing for here, you do the same thing for here. 1, 2, 3, 4, 5, 6, 7, 8. So you do the same thing here, 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 do the same thing here. It's very tiring, so I do another one here. So this would go from 128 to, I believe, 192. Yeah. Let's check it again. Actually, 191. Yep. That's not 64, is it? That's 30. Well, actually, that's 64. I was actually correct. So now it will go to 191. So for 191, you know you're going to have a 1 here. 128 taken care of. And you're going to have, no, you're not going to have that because 64 will make it 192. So it's off. So this is going to be a 0, but certainly you have a 1 here. Have a 1 here, have a 1 here. So you have 128 plus 32, which is 160. 176 plus 4, 180. You have to have a 1 here, a 1 here, a 1 here. So we know we have 128, and we know we're going to have 255. 255 subtract 64 from it. Whatever that's left is what it is. So let's actually calculate that. Okay. So you have 128 here. You add it to 32 and add it to 16. 160, this 176, and you add that to 8. 176 gives you 184. So you add 184 to 4, you have 188 plus 2, 190 plus 1, 191. So this is actually correct. And you know now from this that the other ones are full. That the net mass, they are full. They are full, okay? These ones are full. 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 So the range for a class A is already noted. So this is class B. This range is now noted. It's 64. It starts from 128 to 191. While this other one starts from 0 to what? 191. So we keep doing that. For class C, normally we use up to class C. I've never seen anybody use class D at all. So normally we always use class C. Class C, it defines an address ranging from 192. When you see that 192, whatever, you know it's class C, and it's not even public. These are private IPs. Okay, they are not even public. They are classful IP. These are not classless. These are classful IP addresses that is established by the task force that looks after IP addresses. So this is established. So when you look at the range from 192 to 233, this represents all of the addresses with a 1 for their first 2 bits. See? With a 1 for their first 2 bits, but without a 1 for their third bit. So what it's saying is when you see something like this, so when you see something like this, you see something like 1, 1, 1, it has something here, it has something here, it has something here, and you have another one, you have another one, but there's always one at their beginning first two bits. Is class C. The same thing here, as you well know. When you see one here, you see one here, you see one here, you see one here, it's telling you this is class B. Class B is always going to be only here. That's it. That's how you know it's class B. Alrighty? And then class, like I've shown you here, class B is always going to be only here and here. It's going to be like this. You're going to have that one, initial one here and here. Then you know it's class B. Then class C is going to be different. It's going to have that one in 3 places. Then you know this is class C addressing. So it's not complicated at all. But you have to pay attention to understand how it all works. So going back to our little book here. This is our reference book here. Oh, that's not the one I wanted to take a look at. So going back to our little book here. So class C is, you have it in this form, and class D you have it in this form, and class E you have it, everything is occupied in this case. So class D, you have it in this form, like you have everything, the third of them are classified, that's class D. So class C is the 2 of them are, oh, I made a mistake here. In class B, I was right, it's only this one that's occupied, so sorry. It's only this one that's occupied. Okay? This one. Then class C, you have the 2 of them occupied. Because in class C, it says that it starts from, it's going to jump over some bits. Let's look at it again. You see it jump over some bits. Like class C here, jump over some bits. It says it goes from 192 to 223. Okay? 192 to 223. That's the range for it. But when you look at it, it has to have something here too. It has to have something here too. So that's why they call it class C. Okay? Then class D, it has to have that one in all of the 3 octets as the beginning bits. You have to have that one in all of the 3 octets as the beginning bits. And then in class C, it has to have that one in the first 2 bits. But without a 1 for their 3rd bits. You see where I'm coming from? And remember, when they talk about the bits, talking binary, they're all spread out to 8 different positions. That's how you keep that in mind. They're all spread out to 8 different positions. Okay? So now we have stopped here in 191, so that means we have to start from 192 to get 192. So what we need to do to get 192 is almost the same thing, only that this time we let's see, to get 192, okay, we have to do 128 and 64. Then the rest will be a 0, right? 0, 0, 0, 0, 0. All right. So we have 0, 0, 0 going all the way. Yeah. I don't like doing this, but I'm gonna cheat. I'm going to cheat. Copy. Paste it. Copy. Paste it. So for this one now, you're gonna have, it's gonna end in 223. So you're gonna do a 223. So it starts from here and ends in 223. Alright, so that means all these things are open to be populated. These are open for the taking. Alright. So if you have this set up this way, this is class C here. So remember what it says when we read it in that book. It says class C is defined as the address ranging from this to this. This represents all of the addresses with a 1 for their first 2 bits, but without a 1 for their third bit. So it simply means we could also have a 1 here, but not for here. Okay, there's another way to write 191. There's still another way to write 191. This is 128. There's another way to write 191, but I think this is pretty accurate. This is pretty accurate. So now we have satisfied this condition of 10 here. We have satisfied the condition of 10 here, and we have satisfied the condition of 110 here. So we're going to go to the next one now. So we know this one ends in 223. So the 223 will be, how do I calculate that? Okay, I know I have 1 here and I have another one. This is 192. 223, 192, I will have to deal with 31. How do I get 31? Alright, to get 31, I know 32 is out, so it's gonna 32 is out, it's gonna be a 0 here. It's gonna be a 0 here because 32 is out. So I'm gonna have 1 I'm gonna have 1 here. I'm gonna have 1 here, 1 here, I believe. I'm gonna have 1 here. That's the 16. I'm gonna have number 1 here, and I'm gonna have 1 here. I'm gonna have 1 here. I think I'll have a 0 here, so that when I calculate it, it will be sound. So now I know this is 16. I know this is 8. That's 24. 24 plus. I know this is 8. 24. 24 plus. What is 28? 28 plus 1 is 29, and then 29 plus 192. So let's see. So you have 128 plus 64, which is 196. So when you look at 196 plus 29, yeah, 196. Let's calculate that. Calculator. So we calculate that. So we have 1 48 plus 30, 64 is 196. Actually, it's 192. Sorry, 192. So we added 32 is out. Okay. So we added we said plus 16, and we say plus 8, and we say plus 4, and we say plus 2, and we say plus 1, 223. So there's a 2 there. So the only thing that we removed there was only 32. So now we have to remove this one and put a 1 there. So that's how we get the right one. So we satisfied that. We have satisfied that, and we are going to copy and paste. Anyway, we're gonna copy and paste all of this so that we don't have to type everything out, and it takes a lot of time. So we're gonna paste that. So this is how it should be. This is your class C. Remember, we have satisfied this. They have those two. First 2 bits are those. Okay, we satisfy that. This taken care of, ultimately taken care of. Then you have the class D. class D addressing. You have the class D addressing here. Let's get back. Class D addressing says that you have 111 as the first 3 bits, but a 0 for the next bit. This address range includes address from 224 to 239. 224 to 239. So remember what I told you where the other one stopped, like this one where it stopped? It stopped here. This is 223 if you remember. So we're going to start from 224. Okay? It's 223, right? We're going to start from 224 as it says it right here. See? 224, that's where we're going to start, and we end at 239. So let's give it a try. So we start at 224. We know this one is 223. So what we're going to do, we're going to make this a 0. 1 goes away, right? So how can we beat this? Okay, 224. How can we get 224 without nothing else? So maybe we can do this. We can do, let's see, we can do just 1 here, another 1 here, another 1 here, I believe. So if you do 192 plus 32, that's 224. So the rest would be like 0, 0, 0, 0, and 0. That's it. And now everything else will be also 0 for here. This class, what? Class D. So the condition of the class D is satisfied here. If you look at it carefully, it's satisfied. It's saying that the first 3 bits has to be this, and then the first 3 bits have to be this, and the rest are 0, which is now satisfied here. And now it will end in 239. Remember, this is 224, 239. The range for this one, I think the range of this one should be 32. They're half it. So the range for this one should be 32. Let's see. If you have 192 to 224, 192 to 224, that's about that. 32. Yep, that's the 32. 192 to 224, that's 32. This one would be 16, I believe. So if you go from 224 to 239, that's about 16. That's the range for it. So now we're going to take care of that. So we know this one is 224, but we need 239. 224 is about, we need 16 to make this happen. So what we're going to do is we're going to do this here, this here, this here, and we're going to do a 0 here. No, let me think again. This is 64, 32, 16. Okay, this is correct. Then we do a 0 here, do a 0 here, do a 0 here, do a 0 here. Alright? Then, interestingly, we know what to do with the rest of them. Right? Because all those are occupied and the range is taken care of. Okay? So if you add this together, you have 224. But you need 239. So 224 plus 16, so absolutely this is not right. This is not right. So what other way can I get a 16 here? So I know this is 224 right off the bat because I know that's where I started here. But I have to add 15 to it to get 239. Righty? So how do I get the 16? I know this I know I can't use that 16 there. This 16 is not gonna be usable. So what do we do? Maybe we should get rid of this, which we know is an 8. So we fill everything here out, and then we should be okay. I believe so. So we take all of that. We take everything here and we put it here. We should be fine. It should take care of it. Yep, it should take care of it. So because this is 8, this is 4, 12, this is 2, this is 3, that's 15. So that took care of everything. And it satisfied the class D parameter. Remember, the class D parameter says that the first 3 bits must be high. They have to be a value of 1s. Okay, once it's there, the follow subsequent ones should be 0. So the condition is met and the range are clearly stated and given. So this is what I wanted to show you guys. Okay, once you figure this out, moving forward, you should be okay. Now I can actually save this up where you guys can play with it. I'm going to save this, and this is where I stop. This is an integral part of day 8. This is an integral part of day 8, and looking at the addressing. Normally we use classful addressing. We usually use class B and C. I've never seen anybody use anything else. So we did A, B, C, and D. I've never seen anybody even use class E. But class E is stating here that for class E, defines addresses between 240 to 255. That's the last of it. And any address that begins with 4 ones is included in this case. So any addressing that begins with 4 ones is included in this case. So I'm leaving you with this to play with this and see if you can come up with the same thing that I came up with for the class B. So I'm gonna say for everyone that's watching this, take a little break and go ahead and do the class B and give me the range 240 to what? To 255. 240 to 255 should be 240 to 255. Should be 16 in it. So let's see if we've made a mistake here. So 224 to 239. It looks like 16 to me. Now 240 again. Oh, 240. All the way 240. Okay. And 255. Okay. But it didn't say 255. So guys, check this out. It says this class define address between 240.0.0.0 and 255, which is usually a subnet mask for this IP class of IPs. Okay. Now it's not saying that it has a range from this to this like the other ones. Watch carefully here. These ones have ranges, but this one, it did not specify ranges. But we do know that from 240, the only place we can go is 255. And now that 255 is all filled up. Remember, we went from 224 to 239. 240 is where we're going to start. So the next, everything is filled up. Does this make sense to you guys? The next, everything is filled up. It didn't have a range where we would stop, but we know that 240 to 255 is about how many? So if you count from 240 to 255, it's about 16. But it didn't specify a range, like it specified from 224 to 239, and then all these ones are filled up. But these ones are already filled up here. So that's the point it's trying to make, that this one is already filled up here. So 240, once all of these are filled up, then you can only get this. All right. So this is the closing of Class E addressing, Classful IP addressing, and I would like for you guys to lay it out for me, and let's see how that one goes. You can come down here and lay it down and start from 240, and then you know all the bottom ones are filled up. So what you're looking at is you're gonna deal with all of this. It's not arranged because the bottom ones are filled up for 255. I need you guys to lay it out for me in our next class. Thank you and enjoy your day. This is Josiah again on Each One Teach One. This is a part of what we missed from last time when I was teaching network. And I wanted to thank Lockdown LLC for supporting Each One Teach One, which is the implementation partner for IT Foundation and AWS Cloud Training, codenamed iFACT. See you guys another time and take care now. Josiah, signing off.